Hello, I'm Ray, the Ray in the Ray Code. In this video, I plan to review the Creational Design Pattern known as Factory. I'll be using Java. I produce and make other videos using other programming languages like C++, C#, PHP, but in this video, I'll be using Java. This video, I plan to cover the whole aspect of this design pattern. I have divided this video into different sections, and I have put timestamps in the margins. I start with a list of reasons as to why a developer would want to study this design pattern. I show you the UML the Game for it gave in a book of elements of reusable software. I provide a code example. I also post that code at my GitHub site and also at my own website, theraycode.org. I have theraycode.com, but I'm using that for another project. I also perform a SWOT analysis as to why a developer would want to use this design pattern. You can find me on Facebook, X, or LinkedIn. Please give this video a like, subscribe, and leave a comment. Tell a friend the Ray Code rocks, and maybe you can repost this video on your own Facebook, X, or LinkedIn page. But most of all, be awesome. 5 reasons studying the factory pattern is beneficial for the Java developer. Encapsulation hides object creation logic within factory methods, reducing direct dependency and making Java applications more modular and maintainable. Code reusability promotes reusability by centralizing object instantiation, allowing Java developers to create objects dynamically without modifying existing code. Scalability supports extensibility by enabling easy integration of new subclasses without altering client code, making Java applications more adaptable to future changes. Improved testing enhances unit testing by decoupling object creation, allowing Java developers to mock dependencies and write isolated test cases efficiently. Consistent object management standardized object creation, ensuring consistent behavior across a Java application, which is essential for complex architectures like microservices. UML defines the interface of objects the factory method creates. Concrete product implements the product interface. Creator declares the factory method which returns an object of type product. We also define a default implementation of the factory method that returns a default concrete product object. Concrete creator overrides the factory method to return an instance of a concrete product. Collaboration. Creator relies on the subclass to define the factory method so it returns an instance of the appropriate concrete product. Hello, I'm Ray of the Ray Code. In this show, I plan to do a demonstration of the factory design pattern. I'll be using Java. The factory design pattern isolates creation logic. We start with creating an interface we call iProduct. iProduct will be our abstract product interface. Our interface will require the user to have a use method. The use method will be implemented by all concrete products. Let's now create a concrete product we call concrete product A. We need to extend it with the iProduct interface or the abstract product interface. The use method is required by the iProduct interface. We can auto-generate it, public void use method, from which we return the message using concrete product A. Next, we create concrete product B. We have the class structure for concrete product B, and we extend it with the iProduct interface, and as required, we add the use method. The code generator gives us use and the add override, inside from which we return the message using concrete product B. Let's now focus our attention on the creator class. The creator class is our abstract factory class, so we make it abstract. Our factory method is our abstract product, which is of type product. Now let's make a concrete creator A, which will be a factory implementation. We have the class structure for concrete creator A. We extend it with the creator abstract class, and we can use the auto code generator to create our factory method. We replace the return null with concrete product A. So we return a new concrete product A. Now let's make a concrete creator B class. Concrete creator B is a class object. We extend it with the creator abstract class. We use the auto code generator to add the factory method. We need to replace the return null, and we replace it by returning a new concrete creator B. Both concrete creator B and concrete creator A are what are called factory implementations. In the main method, let's do our demo. We create a factory for product A. Once we have a product A, we execute the use method and expect output using concrete product A. We do the same for concrete product B. We compile and run using concrete product A, using concrete product B. These are the key takeaways. Encapsulation. The client does not know which concrete product it gets. Scalability. Easy to add new products and factories. Decoupling. The factory method isolates the creation logic. My name is Ray. Keep on coding. SWOT analysis of using the factory pattern in Java projects. S. Strengths. Reduces code duplication. Centralized object creation eliminates redundant code, making Java applications more maintainable and efficient. Enhanced flexibility. Allows Java applications to dynamically determine the required object type at runtime, improving adaptability. Encourages design best practices. Supports solid principles, particularly the open-close principle, by enabling extension without modifying existing code. W. Weaknesses. Added complexity. Introduces an additional abstraction layer which may be unnecessary for small-scale Java applications. Performance overhead. Might introduce minor performance overhead due to the exit method calls and object creation logic. Difficult debugging. Since objects are instantiated through factory methods, tracing errors to specific implementations can be more challenging. O. Opportunities. Improved framework development. Useful in Java frameworks like Spring and Hibernate to manage object lifecycles dynamically. Better dependency injection. Can integrate seamlessly with dependency injection containers to manage complex object dependencies in Java applications. Supports design scalability. Ideal for large Java projects where object creation logic needs to be centralized and controlled efficiently. Key threats. Misuse in simple applications. Overusing the factoring pattern in small projects may result in unnecessary complexity with little benefit. Potential overhead in performance critical applications. Excessive use of factories can slow down performance in real-time Java applications requiring minimal latency. Increased learning curve. Junior Java developers may struggle to understand and implement the factory pattern effectively, leading to misimplementation. That was my video. I plan to create these videos each week. Follow me on Facebook, X, and LinkedIn. Check out theraycode.org and .com. Leave a comment, subscribe, and like. Be good. The Ray Code is awesome.